the gross and net calorific value of a coal sample. Calculate the gross and net calorific value of a coal sample having the following composition. Calculate the gross and net calorific value of a coal sample having the following composition. Having the following composition. Carbon is equal to 80%. Carbon is 80%. Hydrogen is 7%. Oxygen is 3%. Sulfur is 3.5%. Nitrogen is 2%. Ash is 5%. Okay. Calculate GCV and HCV. We know latent heat of condensation of steam is 587 kilocals per kg. Okay, I'll give you 3 minutes time. Easy. I think it's a very easy numerical. You can just directly substitute in the value. Okay, are you done with the numerical? Okay, leave it. Okay. Uh, can you tell me now which formula is used? So which formula is used? Long formula. I'll get back to my formula. 1 by 100 is equal to HCV or GCV is equal to 1 by 100 into 80 into 8080 plus 34,500 into H is 7, 7 minus 3 by 8 into plus 2240 into 3.5. Obviously, kilocals per kg. Okay, and I'm not considering the percentage of nitrogen and ash because they actually does not affect the calorific value. Ash is actually a content which is disagreeable for a fuel. Okay, now what's the answer? This will be 1 by 100 into what is 8080 into 80 equal to 8080 into 80 is equal to, hey,
Six
ఏంటి
46,400.
ఏమ్మా
6,46,400 man.
అలా 6 lakhs చెప్పకు, నెంబర్స్ చెప్పు.
646,400.
646
400 man.
400 plus how much is this? LCM 8 తీస్తే ఎంత? 56 minus 3 అంటే 53 by 8.
Yes ma'am.
ఎంత అవుతుంది? 3500 into 53 by 8 ఎంత? Hello, what are the rest batch in the class doing? Please, one, it's not just every time Musha or some only one other girl supports me. Come on, come on. I have so much to conclude. These are, one question is compulsory, either this calorific value or just tomorrow we'll do one more numericals, that is air quantities. Any one of this question is compulsory in your mid and final exams. So no option but forget it and clearly in your head. Tatma, my friends are not remaining 40. Will copy paste from your answers in mid but not in the final. తర్వాత న్యూమరికల్ ఇస్తారు, ఒక ఈజీ క్వశ్చన్ ఇస్తారు కాంబినేషన్. ఈజీ క్వశ్చన్ వస్తుంది కానీ న్యూమరికల్ రాదు. దట్స్ అ ప్రాబ్లం.
228.
562.5.
Plus 7
ఇదెంత? 7
700.
700
Ma'am, 7700.
7700. ఓకే, కిలో క్యాల్స్ పర్ కేజీ. ఇవంతా యాడ్ చేస్తే ఎంత వచ్చింది ఆన్సర్? అబౌట్ బాయ్స్ ఇన్ ద క్లాస్, గుడ్ మార్నింగ్. Did you wake up? పృథ్వీ చేస్తున్నావా? ఇంకేంటి హర్షిత, అక్షయ, మీరంతా? శ్రీజ, వాట్ సోమేష్?
కెమెరా ఆఫ్ మ్యామ్.
కెమెరా ఆఫ్ అయిపోయిందా? సరే, ఇప్పుడు ఆన్.
ఎస్ మ్యామ్.
ఇప్పుడు చెప్పండి, నాకు ఆన్సర్ చెప్పండి. ఇప్పుడు ఆన్ అయినా ఆఫ్ అయినా నో డిఫరెన్స్. మీరు ఆన్సర్ చెప్తే అది అవుతుంది.
Ma'am, 882.
1 by 100 into
882. 662
662.5
0.5
కిలోకాల్ పర్ కేజీ. అమ్మా ఇప్పుడు నాకు ఆన్సర్ వచ్చు ఎలా, ఇంకో 2 తర్వాత పక్కన పెట్టాలి కదా. సో 8826.625 HCV or GCV is equal to kilocals per kg. Okay, next LCV will be equal to LCV or NCV is equal to HCV minus 9H by 100 into 587 kilocals per kg. Okay, that will be equal to 8826.625 minus 0.09 into hydrogen anta 7 into 587 kilocals per kg. Enta answer? Hello, what is the answer? 9/h అన్నా ఉంచండి మీ ఇష్టం, ఇట్స్ అప్ టు యూ. చాలా ఈజీ, జస్ట్ ఆ ఫార్ములా మగప్ చేయటమే.
మ్యామ్ అక్కడ 6600 కాదు మ్యామ్,
ఏనా
సల్ఫర్ మ్యామ్.
సల్ఫర్? సల్ఫర్ ఏంటి? 7700 కాదా?
నో మ్యామ్.
7840 ma'am.
7840.
840.
ఇది కరెక్టా? నెక్స్ట్ ఆన్సర్స్
882802 ma'am.
882802 నా?
02.5. Yes ma'am.
అప్పుడు 28 అవుతుంది అంతే కదా? 8828.025 వస్తుంది అంతేనా?
Yes ma'am.
అప్రాక్సిమేట్లీ మీరు ఎగ్జామ్ లో ఇది కరెక్ట్ గా చేయండి. ఇది ఎంత వస్తుంది ఆన్సర్ అయితే? ఏమ్మా ఏం పృథ్వీ, ఇందాకే చెప్పేశావు గబగబా. ఎంత ఆన్సర్?
8458.215.
ఎంత?
8458.
8458.215
0.215.
kilocals per kg. How about the rest? Easy, correct? Did you do it or easy just helping you out? Okay, easy calculation, direct substitution kits. Just I made you do it to make you acquaint, to say hi to this. It's only that. Okay, did you do it? No, one more one. Then we'll go ahead with the next idea. Okay, easy, very easy one. So that one more numerical we'll do, we'll introduce ourselves to combustion problems, combustion topic, and we'll stop, and tomorrow only do numericals and conclude the chapter. Okay, in fact, yeah, we can extend to introduction to composites, just half an hour or 1 hour lecture, not more than that. Almost finishes my syllabus. Rest all, I think your friends have given nice PPTs. I see, come on. You like 3, I think 2 presentations are on this fuels topic, I think. Okay, one is given by Rahman, the other is given by who? Siddharth and all. Very nice introduction PPTs. Now, can I play just like that? No, I can play those PPTs, do a revision if possible. Okay, but obviously there are no other PPTs on this. So in this chapter, one more biodiesel. I think one we have. Your friend has given one or two. I think. Let me check. And I want to play the entire syllabus, what all corrosion and all you people have presented. And of course, green chemistry, I will not teach much. Okay, I'll move to the next topic. Okay, next numerical. Please take down the question. A sample of coal has the following composition by weight. A sample of coal has the following composition by weight. Okay. Carbon 90%, carbon 90%, hydrogen 8%, sulfur 1%, no, carbon 90%, okay, hydrogen, no, there's no hydrogen, please check, sorry, oxygen 30%, oxygen 30%, sulfur 0.5%, sulfur 0.5%, nitrogen 0.5%, and ash 2.5%. Ash 2.5%. Okay. Ash 2.5%. Okay. It is given LCV or NCV, net calorific value, or low calorific value is equal to 5490.5. No, 8490.5. 8490.5 kilocals per kg. 8490.5 kilocals per kg. Okay. Calculate HCV and percentage of hydrogen. Calculate HCV or GCV and percentage of hydrogen. Okay, do this numerical. Okay. Okay. Will you answer the question so that I can start with the last topic of this chapter? Okay. So again, I'll get back to my discussion. Okay. Huge, I think, lot of data is required for this. What is the answer? Can I distribute the work among all of you? Okay. Now what is it? HCV is equal to 90 into 8080 plus 34,500 into capital H, which is what we have to find, minus oxygen is 30 by 8 into is it plus 2240 into 0.5. Okay. I also know that, okay, let me first summarize this. So HCV is equal to kilocals per kg. The units are kilocals per kg. So HCV is equal to, what is 90 into 8080?
727200.
Tama?
72
72
72
72
00.
plus 34,500 into 8H minus 30. Can I take 8 out? Huh? Plus enta 2240 into 0.5. 2240 into 0.5. Hey, what all the other students doing, please? Huh? Come on.
1120, ma'am.
1120. Yeah. So HCV will be equal to, ఈ రెండు యాడ్ చేయండి. What is a net? How I should write here? What is the value?
728320.
728320 plus 34,500 divided by 8 into 8H minus 30. Okay, is one equation. Okay, next I'll take down next equation. HCV is equal to LCV, that is 8490.5 minus 9H 0.09H into 587. Correct? This is the second formula. Now can I equate the both? So 8490.5 minus 0.09H into 587 is equal to 728320 plus 34,500 by 8, 8H minus 30. This will conclude 2. Elaga. I take this here. I'll get that here. So
Ma'am, HCV is equals to 8490.5 plus no, ma'am.
HCV కాదు. Plus, sorry, plus, correct. I'm sorry. Correct, perfectly correct. Okay, so shall I get that here and take this that side? ఇది ఇప్పుడు 0.587 into 0.09 ఎంత? 587 into 0.9. నేను కూడా క్యాలిక్యులేటర్ పెట్టుకుంటే బెటర్ ఏమో. 587 into 0.9. హలో ప్రతిమా వాళ్ళు ఏం చేస్తున్నారు? హలో, ఆర్ యూ రైటింగ్ సంథింగ్? చక్కగా కాపీ పేస్ట్ చేస్తున్నారా? ఏముంది తుస్ ఐ నో ఇట్ అని అంటే తొందర చెప్పండి. ఐ హావ్ నెక్స్ట్ పాయింట్ టు టెల్ అండ్ కంక్లూడ్ ద క్లాస్.
52.83.
ఎంత? 0.098 into 587.
Yes, ma'am.
52.83 H minus 34,500 by 8 into 8 ఇది 8H minus 30 is equal to 728,320 minus 8490.5. ఏమంటావు ఈ ప్రాబ్లమ్స్? ఓకే, ఎంత? Hey, what are others doing in the class? Only few are answering, taking rest. What? ఏంటి? హలో ఏంటి సోమేష్, why did you raise your hand? చెప్పు. హలో సోమేష్, just like that you raised your hand. హర్షిత, మీరందరూ ఏం చేస్తున్నారు? వైష్ణవి, నిఖిత, శృతి, కీర్తి అండ్ what? Naushin, Sanjana, Shrishma. Hey, are you copy pasting or tell me quickly? Siddharth, Shekhar, Neeraj. Hello, come on, finish. I don't want to do this time waste on this, but we have to find it. ఎలా చేస్తున్నారు? ఇదెంత వాల్యూ? ఎంతో కొంత వస్తుంది కదా.
719,829.5.
19,829. And who is
0.5.
this? అమ్మా. 19,829. Have you done that? What's the answer? Tell me. Give me the net answer. What is HCV is equal to percentage of hydrogen? Please cross check. I want to move now to the next topic. Last topic, important topic. Last, these two are important kids. Like this, numericals will be given in your exam. Okay, they'll ask. These are the two types they have generally asked till date. Percentage of hydrogen calculation and HCV GCV calculation. Okay, so what is the answer? You can solve this, is it not? Point is, I don't solve these numericals otherwise. Okay, shall I move on? Will you answer this numerical answer tomorrow? Okay, please do it. Okay, no, hold on, leave the contents where they are, and I shall discuss the next one. Okay, right. Combustion calculation of air quantities. I'll finish in 10 minutes time so that you can also get relieved. And I know what is the pressure of sitting in a class on a Sunday, but no option for us. Just 2 or 3 more days. That finishes my lecture sessions with you, and you can say bye to me. Okay. I'm also getting equally a lot of phone calls now. That's my problem. Come on, kids. Right? The heading, combustion, calculation of air quantities. Did you all get any message regarding the holiday? Tomorrow or day after? Eh? What's the schedule? Tomorrow or day after is your holiday? Okay. 10 minutes time, 15 minutes time will finish. Right. So there are some 10, I'd say, rules which are applied for calculation of air quantities. Important one. Okay. Combustion and calculation of air quantities. Combustion, calculation of air quantities. చెప్పింది జస్ట్ విని అండర్స్టాండ్ చేసుకోండి. Any doubts, you can raise your hands. Okay, I'll finish as early as possible. Okay, so for this to understand, I need to ask you a question. What is combustion? What is combustion? Huh? What is combustion? What is combustion?
Burning in the presence of oxygen.
Okay. Yeah. Burning of a fuel in the presence of oxygen. Next, Somesh, tell me, will uh, will air contain only oxygen or other gases as well? The composition of air is only oxygen or any other gases that are present? Chippu?
Other gases.
Other gases are also present. Now, but it is a general terminology. Whenever I spoke about the combustion, I kept on telling that it is burning the fuel in the presence of air, which supplies oxygen. So air supplies oxygen for combustion. Okay, so air supplies O2 for combustion. That's a known thing. But air does not have only oxygen, but there are various other gases that are associated with air. So how much amount of air should be supplied so that the combustion is 100% is the subject of discussion now. That means for the complete burning of the fuel, how much air has to be supplied so that it can give the required oxygen for complete combustion of the fuel. If not, what will happen? Carbon, instead of getting converted to carbon dioxide, it goes into an intermediate state of carbon monoxide. Okay, and this again takes oxygen to form carbon dioxide. Partial or incomplete oxidation decreases the calorific value of the fuel, obviously. Okay, and hence calculation of air quantities is very, very important to ensure complete oxidation of the fuel. And hence there are some 8 to 9 rules which are generally used for the calculation of air quantity. Okay, and point dot after dot we'll write the rules, 9 rules, and we'll stop the session today. Okay, what is the first rule? Okay, air quantities. Then what's the point you write here? The following rules are applied. The following rules are applied for calculation of air quantities. For calculation of air quantities. Okay, write down the first one. The first one, substances combine in definite proportions. These things you know already, but here we are using. Substances always combine in definite, law of definite proportions, kids. Always combine in definite proportions. We know that. But we'll do the weight calculations now. Okay. How? We know that for carbon, 1 kg of carbon or 1 unit mass of carbon for combustion, how much amount of oxygen is required? For combustion of 1 unit mass of carbon, uh, for carbon combustion, how much O2 is required and what it will form? Okay, we know carbon, which is a solid, reacts with oxygen, which is a gas, to form carbon dioxide, which is also a gas. Is the equation balanced? It is balanced. Okay. So when I consider the mass proportions, okay, what I can get will be important for the numericals. What I can say that 12 grams of carbon will react with 32 grams of oxygen to form 44 grams or kgs of carbon dioxide. Okay. I know that 12 grams of carbon will react only with 32 grams to form 44 grams. This is the definite proportion of combination with respect to complete combustion of carbon. Okay. If I take the complete combustion of hydrogen, okay, this is the first one. Now I want to take that of hydrogen. Okay. For hydrogen, what it will be? For hydrogen, complete combustion requires how much amount of O2? Okay. So I'll take hydrogen. In the case of hydrogen, it is little more complicated, but the ratio of combination is the same. So hydrogen reacts with oxygen in the kerasa to form H2O. 2 grams of that this is the balanced equation. So I know that 4 grams of hydrogen reacts with 32 grams of oxygen to form 36 grams of H2O. Okay, this is the ratio of combination here is 4:32:36. Okay, so ratio of combination is 4:32:36 grams. Okay. So, but what we do here is that we consider the available hydrogen. That will take little later. Okay. So this is the discussion about the combination of the individual elements in definite proportions. This is the first law or rule which I'll follow. I'll consider the law of definite proportions. Okay, I'll consider the law of definite proportions. That's the first one. Okay, now write the second law. Okay, what does the second law tells? It's a known thing. Okay, at STP, any 1 mole of gas occupies how much amount of volume? At STP, this is a MCET question.
22.4 liters or
That's it. Good. Okay. This is the second law. What is the second law? 1 mole of any gas. 1 mole of any gas occupies 22.4 liters of volume at STP. That's it. That's the second law. Okay. That means 44 grams of carbon dioxide occupies 22.4 liters volume. Whereas in the case of hydrogen, 4 grams. Okay. 4 grams or H2 ante 2 grams. 1 mole ante 2 grams of hydrogen occupies 22.4 liters volume. That's the second law. Easy, known one. Okay. అయ్యో ఇదేంటి బోర్డ్ కనిపించట్లేదు మీకు. Next, the third one and most important 3-star mark. First, the law of definite proportions and this one are the important rules for calculation of numericals. Okay, I understood that air does not contain oxygen 100%. Okay, so how much amount of air, how much amount of oxygen is present in air? So air contains 21% of oxygen by volume, O2 by volume, and 23% of O2 by weight. This is the block point rule. So air contains 21% by volume and 23% of oxygen by weight. This is the star mark point. Star mark point. Okay. Therefore, for supplying 1 kg of oxygen, we should supply how much amount of air? Calculate. Air contains 23% by weight and 21% by volume. Okay. So, for supplying 1 kg of O2, how much amount of air has to be supplied? Amount of air to be supplied is equal to how much? Amount of air to be supplied is equal to how much? Enta? Percent ante ela cheppachu? 100 kgs of air contains 23 kgs of O2. Okay. So for supplying 1 kg of O2, I need to supply how much amount of air? 100 by 23 kgs or 100 by 23 enta? 4.35 kgs. 4.35 kgs of air. So I can write for 1 kg of O2, 100 by 23 or 4.35 kgs of air has to be supplied. Block. Numericals. Okay. Did you write this? I'll finish quickly. So this will take little more time. Okay. Next. For supplying 1 meter cube of oxygen. Now what is the one? For 1 kg of oxygen, by weight it is 23. So if I want to supply, for supplying 1 meter cube of O2, how much amount of air is required? Okay, I know that 100 meter cubes of air contains 21% of O2 by 21 meter cube of O2 is there. Okay, so for 1 meter cube of, this is volume of air, how much amount of air has to be supplied? For 1 meter cube of oxygen to be supplied, I need to supply 100 by 21 meter cubes volume of air, which will be 4.6 4.76 meter cubes. 4.76 meter cubes of air. These are very important formulae for numericals. That's it. I can't say any other word more than this. So whatever you're putting in the block, apply. That finishes the numerical part of your exam. Okay, so last these today's, yesterday's, and tomorrow's class are sufficient for you to solve at least 2 questions in your mid-exam. As simple as that. Did you take this? Now, this is the third point. Okay. Now take down the fourth point. Fourth point, molecular mass of air is equal to 28.94 grams per mole. Fourth point, molecular mass of air is equal to 28.94 grams per mole. Okay, the fifth one. Minimum amount of O2 required. Minimum amount of O2 required is equal to theoretical amount of O2. Theoretical amount of O2 which calculated. Theoretical amount of O2 calculated minus O2 present in the fuel. That is in the combined state. Okay. Sixth point. If combustion products, this is important. If combustion products contain carbon monoxide, O2, etc., excess oxygen should be considered. In fact, subtracted. Excess oxygen should be considered. Mass of the gas is calculated using the formula PV is equal to nRT. Mass of the gas is calculated using PV is equal to nRT formula. Okay. Next, eighth one. Total amount of hydrogen total amount of hydrogen is equal to available hydrogen plus fixed hydrogen. Okay. Okay. This is what just now we discussed. If total amount of hydrogen is capital H, available hydrogen is equal to H minus O by 8. Why? Fixed hydrogen is O by 8. How I got that O by 8? It is total oxygen divided by 8. This is the formula. Okay. Now, the last one, I'll stop the class here. Last one. Formula for calculation of, I'm rubbing this. Formula for calculation of theoretical oxygen by weight. By volume and the correct kadu, by weight. Formula for the calculation of I'll give this formula and I'll conclude the session. Formula for the calculation of theoretical amount of oxygen required. Okay. For supplying amount of oxygen required. Remember kids, by weight. This is important. By volume, not much applicable. You'll get wrong answers if you don't do substitution directly in a proper way. For amount of oxygen, okay, I'll come to the formula. Amount of oxygen is equal to 32 by 12 into capital C plus 8 into H minus O by 8, H minus O by 8 plus capital S. Okay. Formula for amount of oxygen required. Okay. Units are grams. Units are grams. This is the formula, kids. Please do write it. I'll stop here. Okay. Formula for amount of air required. Amount of air required by weight. I'll get to the formula. Obviously, amount of air and so many grams of oxygen ki. I know that 100 by 23. I have to multiply it with 100 by 23. So for air, it is 100 by 23 into 32 by 12 into C plus 8 into H minus O by 8 plus capital S grams. I'll stop here. Today is Sunday. I'm not taking the attendance. Okay. What's the time? Correct, 12:30. Solid 2 hours, that's it. Tomorrow we'll conclude the numericals and conclude the chapter. So these are the formula. Why Siri is very eager to leave the class. Anyways, it's great that on Sunday you have joined me for the session. Good day to all of you. Did you write the equation? Okay. Tomorrow again at 10:30. Okay, 10:30. I'll post it in the group. Okay, bye. See us. Usha and Neeraj, please coordinate. Tomorrow again by 10:30. We'll do the numericals and conclude the chapter. Okay?
Ma'am.
Bye.
Ma'am. Ma'am, ఇందాక హెచ్ వాల్యూ మైనస్ లో వస్తుంది మ్యామ్ మీరు చెప్పింది.
మైనస్ లో రాకూడదు, అది సరిగా క్యాలిక్యులేట్ చేయనన్న.
లేదు మ్యామ్, ఎన్నిసార్లు క్యాలిక్యులేట్ చేసినా మైనస్ లోనే వస్తుంది మ్యామ్ హెచ్ వాల్యూ.
అయితే నేను ఒకసారి చేసి చెప్తానే.
మైనస్ 17 పాయింట్ సంథింగ్ వస్తుంది మ్యామ్.
మైనస్ ఎలా అంటే మైనస్ ఎలా ఉంటుంది? అది ఉందంటే మైనస్ ఎలా అవుతుంది? సరే నేను ఒకసారి చూసి నేను క్యాలిక్యులేట్ చేసి చెప్తారు. ఓకేమా? ఓకే, 10:30 or max by 11. Okay, good day, bye.